Denver Post Community Foundation, and we're so glad you could all join us today. This is such a special event because of the excitement around number 844. So we put this event together for you to hear more about everything that just went on. We're so excited to have number 844 back to lead the the Denver Post Cheyenne Frontier Days train. It wouldn't have been possible without the tireless efforts, the countless hours, and the pure dedication of the Union Pacific STEAM team and our featured presenter, Ed Dickens Jr., who is the Senior Manager of the Heritage Fleet Operations. Can we have everybody associated with Union Pacific please stand so we can give you a round of applause? Through support of programs focusing on arts and culture, children and youth, education and literacy, and the basic provision of human services. So we want to say thank you to all of you for your support. You're helping that mission in the community. And then I want to give a special thanks. A lot of our helpers are out there, but we have our team here today. Tracy Ulmer, if you want to stand, Executive Director of our foundation. We've got Renee Wheelock, we've got Liz Brown, Betsy Batts, and Jill Colby. Thanks, Jill. So thank you so much. We hope you enjoyed today. I'm going to let you hear from who you're here to hear from, and we're just so thankful. Please welcome Ed Dickens Jr. Enjoy.
Well, thank you, everyone, and it's a pleasure to speak to you today on behalf of the Union Pacific and our crew. They were going to be here, but they're over working on a locomotive, and that's the theme of what we're going to see today. Working on a steam locomotive. Well, this journey began in earnest really in early 2015. We were involved in returning the 4014 Big Boy in 2013. Earlier in the year, right about 3 years ago, we discovered a condition on the locomotive that we needed to investigate further, and that is what led to the work scope that we did. All right, this presentation is dedicated to the thousands of men and women of the Union Pacific Railroad and our crew. We can't do anything without the support of the nation's finest and biggest railroad. This is a project that is closely monitored by many, many people in our corporation, and we enjoy their support on every level. And as the locomotive is not operating, that of course brings to question why? Why isn't the locomotive operating? And I tend to be really technical about those explanations, but the end question is, we need to have machines like this operating to continue to preserve our heritage. So we're going to jump right into it, and again, I tend to live in a really technical world of blueprints and a lot of technical discussions, and it's my life, and I'm very blessed to work in this occupation where I can live that. So if I get a little overly technical about things, and I'll try to monitor everybody's posture, and I'll just try to keep moving right along here. But this is the boiler as we begin to take the jacketing off, and we found just some deteriorated things. Some sheet metal jacketing and lots of insulation that over time, the jacket that was applied didn't provide real good watertight conditions, and that saturated that particular type of insulation. And that, of course, led to a lot of deterioration of the boiler.
Wow.
And this is the steam dome, very critical part. Every part of this pressure vessel is critical. This part in particular, as with all parts of the pressure vessel, have to meet engineering requirements. And that involves that you measure the thickness of the metal. Well, how do you measure something that rusty? You have to clean it first. And so we began a process of just determining where do we begin. And again, more parts of the boiler, lots of rust. Got to remove that rust before we can get into our analysis. These are stable caps, so those needed to be removed. And when they were removed, you could see, if I can get my mouse over here, just scale and rust and things, nothing really that you wouldn't not expect to find on a steam locomotive, but all that needs to be cleaned so you can continue to do your investigative discovery. little bolts and things welded on the locomotive that we need to remedy. The design of the locomotive is such is that all of the things that attach to the boiler, there's a drawing there, and there's a process of installing studs and other things that hold all of the things that you see on the locomotive. And we took the cab off the locomotive and we found this wrench. I'd wondered where that wrench was. But, you know, a steam locomotive, it's such a big utilitarian tool. And when we were putting it together, we had to be careful and keep track of things too, especially as fast as we were putting everything together. We've got a special team in there removing some insulating material. Little things like that, as you discover those things, it kind of adds to your timeline, and it's unexpected, and that's part of any restoration effort. You've just got to, it's hard to plan for all those little details, but it's just something that you have to address. This is the cab frame. As much as we love having the locomotive in original condition, there comes a time when those components just, it's not practical to continue to keep them in service. So we built all new frame pieces for the cab deck, and lots of parts on that locomotive are new. If you look at that, you can kind of see, not only is there a lot of rust under there, but it's starting to look to the point to where it's almost not serviceable. And when you disassemble that, you torch cut all those bolts and you get everything apart. Well, how do you put it all back together again? You got a bunch of rusty, bent up, torch cut parts. And when you put it back together again, chances are it's not going to look very straight. So we from the beginning, we decided we're going to make all this new. And that's the old cab floor. And today you'll have an opportunity when you go over there and you can see, and just standing back looking at it, you'll be able to see what is new. Some more cab pieces. Those were up behind the elephant ears. For those that know what those are those big metal plates right up alongside the smoke box. And again, you know, they're probably original. That's probably 1945 diamond plate right there. It had been removed over the many years that the locomotive goes through its shopping. And we needed to remove them too to gain access to the steam piping that was underneath that. So as we pulled those out, we added that to the list of the things that we would make new. We have all the blueprints, so we can take those blueprints and make a modern CAD file, and we can send that file to a metal processing shop, and they can process that metal for us. And we get back that piece of steel that's cut. Some of the holes are in it, and all we have to do is make a few more holes in it, do a little bit of grinding, possibly a little bit of bending, and we reinstall it. And you can see all those hexagonal caps. I'm going to turn here so you explain it a little bit better. It's hard for me to see that screen. So we have all the stay-bolt caps there that we have to reinstall back on each one of those, what's known as a stay-bolt sleeve. And I'll have some pictures as we go, so I'll be able to refer back to that. So each one of those caps threads onto a sleeve that has to be addressed. So we made up all kinds of special tooling. You know, it's one of these projects where as you get into it, you have a list of the things that you're going to need, and you continue to add to that list. And you wonder, when does the day come when we stop adding to this list?
Dangerous time.
You can also see here, we removed the inside portion of the firebox. For a number of years, the locomotive was put back in service in 2004, and the inside part of the firebox, not where the water is, but where the fuel is burned, behind what we call refractory, I'll have a picture of that as well. The locomotive burns oil for fuel, and that oil produces a very tremendously hot fire. And so that portion of the firebox is lined with that special refractory brick. Well, unfortunately, moisture was able to accumulate in some of those areas, and it deteriorated not the side that the water's on, but the side that the fire is on. So as we disassembled that firebox, we discovered that firebox plate very deteriorated. Some of it, visually, you could tell this isn't going to be any good anymore. And of course, when we put our UT analysis to it, you know, that confirmed what we already saw. So all that was added to the list. And here we are looking up above. A boiler stripped down with nothing on it. No cab, everything is stripped away from it, so we can assess every steam, every stable, every stable sleeve, every cap, every part of that boiler has to be evaluated. Parts of it, when it's attached to the frame, are hard to get to. Luckily, I'm a pretty thin guy, and some of that work I assigned to myself to climb in there and just clean it, and get all the scale off of it, and do our readings. We had over 10,000 ultrasonic test points on the boiler. And our boss, Scott George, I've never seen anybody run an Excel program like him. And so he's helped us with a lot of those technical details and some of the computer processes. And we have these fabulous Excel spreadsheets that detail this process. So we can enter all that data into an Excel. And I don't think there's a printer big enough to print it out. But it's truly, it paints the picture of what we needed to replace. And that's a threaded connection where we would screw in what's called a stud. Right here, there's a new one and there's an old one. And we weld that nut on there in order to unscrew that stud out of the boiler. And this stud here was in a place that you could get to because it would have broken off if it was in a hard place. So that was the one that actually came out. And here we are going back together again. Once we get the boiler cleaned, we determine that there's no weld repairs or patches needed on the exterior part of the pressure vessel. Now we can work toward painting it. Because we don't want to have a repeat of that level of deterioration. So we want to do everything we can to protect the exterior of the pressure vessel, which you can't see. It's underneath a layer of insulation, and it's underneath a layer of sheet metal jacketing. So you can't really monitor that. Typically, you would remove portions of that jacket and assess certain things. And that's our plan going forward. We'll make sure that that paint condition is still in good shape. If it's not, we'll make it good again. This is a stud here that holds, as that tag says, a handrail. That's a pretty important one. Up here, you can see this thin piece of metal welded to that casting. That's a pipe bracket for the pipe that delivers water into one side of the check valve. This stud right here, let me find my arrow again. This stud right here had broken off, and a piece of angle iron was welded to the boiler in place of that stud. Well, the weld broke, and for who knows how many years, when that locomotive would expand and contract, and as it's going down the track vibrating, and as that pipe is moving, as it does with hot water, cold water, cold water, it just slowly was sawing its way down into the pressure vessel. So that was an area that we had concern, because now you've got a thin section. So we've got to make the determination, should we cut that piece of shell out, or is it best just to leave it be, because it's not at the minimum thickness. It's quite a ways from that. But those are part of the assessment process. So we get some engineering support and make the right decision. If you can imagine cutting a piece of this plate out, forming it, and welding it back in, certainly can be done. But now we're cutting apart the integrity of that boiler. And the welding processes, they're certainly present, and we would do a great job. But there's aspects of this work to where, once you start doing that kind of work, you're getting into some pretty significant repairs. We've got a lot of internal structures. These rivets you see, all are part of the inside part of that boiler. All that would have to be removed. We've got internal bracing, the front part of what we call the tube sheet. I'll have some pictures of that. So it's not just as simple as cutting that eroded or that worn piece out and welding another piece in. You're getting into a lot of questions of engineering. A lot of new studs. This is the front part of the cab. You can see those nice new studs and all the new staples we put in, all new staple caps. And now we get into the part where we're actually taking apart the inside of the firebox. This is what we call the heat transfer surface. This is where the intensity, the heat energy of the fire is absorbed through that metal and transmitted into the water. And that's how a steam locomotive generates its power. Very critical part, the heart of the locomotive is the firebox and combustion chamber. Well, all of the areas that you see were the areas behind that refractory brick, that fire brick. So as we cut it out, now we can see what's behind there, what's in what we call the water space, where the water is. And you can see this area down here is known as the mud ring. All of this had not been replaced back in its last rebuild ending in 2004, and it was fairly significantly deteriorated. So we took out that as well. All the rivets came out. And if you've ever removed a rivet out of a steam locomotive firebox, you'll know what I mean. Sometimes we'd only get 1 or 2 rivets a day. And we're talking, you'll see the guys, these are pretty big guys. And we've got what we call a rivet buster, which is about this tall. It's almost a 2-person hammer. It's just tremendous. And when the rivet buster's going in the steam shop, you can hear it across the street at the depot. It is really a big tool. So what that means is it represents a tremendous amount of work. And when you're doing this kind of work, it's easy to get demoralized. You know, when is this going to end? You know, we want to run nobody wants to see this equipment run more than we do, more than the Union Pacific does. But we've got to get this work done. We can't shortcut it. We can't figure, well, I think that's going to be okay. Let's just leave that in there and we'll come back some other time and redo it. That time never comes. You know, when are we going to come back and tear it all apart again just to fix that? So it's all going to be repaired. This piece here, we're starting to fit it in, and that's the bottom section of the firebox. And it mates to this surface right here. What you can see here, it's hard to see because it's such a beautiful weld. But this part of the mud ring was deteriorated, corroded. So we cleaned it up and we welded all that through there, made it all back to the drawing. This is a metal template that we make exactly to the dimension of that radius, so we can slide that in there as we're grinding and fitting that radius in there. So when you go to put that new plate in there that we formed in our shop, we can just rivet it, fit it right up in there. We also discovered a condition known as grooving, and that's a condition that can happen over time. You've got the plates are under a tremendous amount of stress, expansion and contraction, and you get erosion that occurs through the stress of the plate bending. We had to fix that as well. And here's that new plate, and we bent this in-house in our shop with this machine right here called a press brake. So we do a little bit of geometry and we lay it out and we start bending. Each one of those lines, there's dozens of bend points that we continue to work that plate through there to get it bent right exactly to that radius. Very accurately machine all the new rivet holes in there with the countersink in them. So when we fit that up, all we have to do is take a special reamer and run it through that hole, put a rivet in, and we're good to go. Is this too technical? No. Okay. It's funny, my boss sometimes when we talk, I've learned to gauge how much I tell the technical side, because not everybody lives the world I do. I'm talking about rivets and this and that, and other people are looking at their watch. Next time they ask me a question, they phrase it a little differently. So here we are putting everything back together again. Several years ago, we bought new tooling for another project we were working on. And whenever we source tools, we can have a lot of the tools that are specific to the power plant boiler industry. They make a really comprehensive line of all kinds of special tooling that's adaptable for what we need. So right here you see a special pneumatic cutter, and we had special tools made specific to what we wanted. So we can fit that mandrel, the part of the tool, inside each one of those rivet holes, and then we drill all the way through and we hold that plate in what we call a fit bolt. A fit bolt represents a rivet, and it holds the plate very securely, and we very accurately machine each one of those fits and each one of those countersinks. Because it looks like it's on a radius, but some of the axis of the hole is at a different angle. It's not at a right angle to the sheet. So you have to know that and have to machine it accordingly. So when we go to put the rivet in, that rivet's going to hold 100%. Each rivet's going to hold its required amount. And it just takes time. Now we've got the additional plate that we're putting up in there. And we formed this as well. We had a local shop down in Greeley do the major part of the forming, and then we did some of the final tweaking. But we weld what we call those ears on there, and we put those big shackles on, and we just lift that thing in and out of the boiler. And when you start a project like this, you're not going to get it right the first time. You want to get it as close as you can, so you're not heating that thing up and beating it in there with a bunch of sledgehammers. So the idea is that we're going to have this in, measure it, and take it out. We put a crane, actually bolted a crane inside the firebox that we could raise and lower, because that's about 140 pounds. And we'd raise it up and then pull it over in position and then lift it right up into that location. And we're getting very, very close to the final fit. And there's the other side. And I want to mention our new welder, Jimmy Thompson. His parents are in the audience here. He spent countless days, amounting to weeks, welding, fitting, and very meticulously grinding what we call our weld line. And that weld has to fit into the symmetry of the boiler, because as it all goes back together, you want all those forces to be symmetrical from one side to the other. The distance between the stay bolts is known as a pitch, so you want everything to be symmetrical within those stay bolt pitches. And here we are fitting it up. We made this template, and what we do is we take and we make a sheet for the very top, one for the bottom, and we accurately weld it together. And then from that, we know where we need to bend it. And it was an offset tapered cone, very, very complex to set up and bend with a machine that makes one bend at a time. But we got it. Because you got to be determined. You can't be a defeatist when you're doing this kind of work. You'll give up. You mess it up, you'll just give up. So there it is going together. Just beautiful workmanship. This is behind the fire brick, so you can't see this. That's why I took lots of pictures of it. And there it is, all assembled back together.
Wow.
Only because I'm one of the few people that really knows how long it took. The second that slide appeared, I got goosebumps. I know it sounds kind of corny, but. So now we've got a repair that's going to withstand 300 pounds per square inch of water that's at 425 degrees. When you see the locomotive operate, when you hear the locomotive operate, that locomotive will be pulling the Frontier Days train. It's got a diesel with it, and the diesel will be helping a little bit here and there. When we come out of Greeley and we head out of car. Other than that, the 844 is doing most of the work. Yesterday, for anyone that was on the train, the 844 took the train all by itself from LaSalle to here. You know, it's uphill. We didn't use the diesel at all. A lot of people want to know, why do you have a diesel with you all the time? Well, they don't realize how much that steam locomotive is really working. And this is how it works. Well, here's some of the blueprints about the stay bolt caps and sleeves. I added this in there, just kind of gives you an idea of what it is. This represents the water space, and this is a stay bolt attached to the outside, or excuse me, this is the fire side here. And this is the outside that you can see with one of those many thousands of caps that were threaded on there. When Scott joined our team, one of the first things he did was he spent several days over there with a tap, one after another, running a tap through those stay bolt caps. He wanted to know, what can I do to help? I said, well, we got some job for you. Remember that?
Thanks, Ed.
And here's one of those CAD drawings drawn by our foreman, Austin Barker. So we'll draw this, and then we can give this to one of our, we've got a forge shop that does the forge work for us to form that spherical head. And we also have another shop that will do this precision drilling of that hole there. And here's an example of some staples. This one was removed from the 844. This one was removed from the big boy 4014. And this was part of the inventory that we had as extra stapled stock. Well, ideally, you want that hole as near as the center as you can get it, because that if it's thin over there, then you can see how that could weaken that bolt. So that would not be usable. We machined with an end mill, machined that ball down so we could get an idea where those where those telltale holes were. And this is one of the new bolts. We've got what's called layout die. We put that layout die on there, and then we can fit it up at each location. And then when it all works out, the truck shows up and we got thousands of them, all heat treated and ready to go. But that's what you have to do when you're going to run a big steam locomotive. And now we're working on, this is the door sheet where we have threaded stay bolts. And this too is just a real arduous process of drilling, reaming, and threading those holes and installing those stay bolts. This went fairly good. We did 88 of them in one day. And when you start out, you're doing 4 and 5, then you're up to 10 or 12, and then 20. And, and by the time we got to that door sheet, we had it down. We did 88. I since got a text message, hey, we did 88 today. You thought it was a typo. And here's one of the many tools that we made. This is known as a stay bolt snap. And this is actual Union Pacific drawing that we've redrawn in CAD, so we can have a tool company make this tool for us. We tell them what kind of steel we want it made out of, and they'll heat treat it, make it right to our specification. Save us time. And that's what it does. It forms that stay bolt over. On the other side, you have a person bucking the stay bolt, holding it very securely. So you're not going to drive it through the threads of that sheet. And it forms it, and as it does, it expands that bolt into the thread and makes it steam tight. On the inside, it forms a radius on there so that bolt does not overheat and crack and eventually fail. It'll leak, and then that becomes more of a problem. Now here is a flexible stay bolt. This is on the outside, actually right about where my feet are in the cab of the locomotive. And we replaced all of those. This is the outside. We had that picture on the inside. Now this is on the outside of it. So each one of those bolts will fit in there and be held uniformly and then welded on the inside. And then a cap welded on the outside. Some more caps. As we started to put the locomotive together, we had no way of knowing how everything's going to line up. Because we're doing it, we're putting new plate in. So the plate that we're putting in varies just slightly from the plate that was in there previous, because we're going off the blueprint. So as we put it together, we made that new piece on the inside according to the drawing. Well, it didn't line up exactly on the outside, so we had to remove quite a few stable sleeves, this whole device right here. You can see the new weld. That's a Jimmy Thompson weld. Get it in the proper orientation with the hole and put that in. Put the locomotive back together. Here's a drawing of the another type of sleeve that we had manufactured. And now we're on to some of the appliances, and the piping, and the valves. This is what's known as a turret valve. The steam locomotive supplies all the energy for all the appliances, air pump, the dynamo that creates electrical current for the headlights, the radio, the injector, the water pump, the blower, the atomizer, the heater for the fuel, steam heat for a passenger train back in the old days. So these turret valves are very, very critical. And they have to be able to close off when you want them to. If you've got a problem with one of the components, you have to close it down. If that doesn't work, you've got to shut the boiler down. And that's several days right there. And then to steam it back up again, that's several more days. So you can see how critical that component is. Well, it too, unfortunately, was pretty deteriorated. And several of them didn't shut and hadn't been shut for a long time. So we rebuilt these. This is the inside, what's known as a stem. And we made new stems for it. And just went through and duplicated all the components. All new studs. Machined the seats. New studs, new stems, new nuts, but we used the old handles. But that is a very, very important part of the locomotive. We also replaced several of those valves that come off of the turret valve. That steam goes to all different parts. As you see the pictures of the cab, you can see all those valves. And each one has a separate function, and it controls the steam pressure to all the various things that make the locomotive operate. Well, if they're all tight and they all work good, you don't need to shut them off every night. But if there's a problem, you gotta be able to, in an emergency particularly, you gotta shut that down. We replaced a lot of those valves as well. That's the inside. Another part, there's so much pressure and so much heat in there. It has a special bronze stem guide that holds that seat. Washout plug, you'll see those as you walk around the locomotive. They're on each corner, and they allow us to wash the boiler out. And you shouldn't hit on those, you know, that they leak a little bit. Guys that have been around a steam locomotive a long time, if there's just a little bit of pressure on there, then you might give it a little tap with a bronze hammer. But the last thing you want to do is beat on that thing. Well, what do you think? It's been beat on a little bit. Probably to get it out when the locomotive didn't have any pressure on it. But the idea is that's another precision machine component. If it's machined precisely and it's cared for, that machine fit will just snug up and it'll seal. That's what you want. And when you go to take it apart, you get a little 2-foot piece of cheater bar, comes right out. Shouldn't have to beat it into submission. There's the new one. And those are very important. It gives you a large opening so you can get in and visually inspect the boiler, but also install your washing tools and washing hoses so you can clean that boiler out. We get 31 service days every time from the time we steam the locomotive up until we have to go through a maintenance schedule. So we want to maximize that. When we travel around the country, we don't always have the luxury of having nice, clean, softened water. We get a lot of sediments and a lot of stuff in the water that we have to manage through chemistry, and then we have to eventually clean that out. Because most of that stuff doesn't steam out. Nice, pure, clean steam comes out, and all that stuff stays in. And that's how we get it out of there. And here's a picture when we had what we call our grid. Each one of those intersecting lines represents one of the points where we're going to do a UT analysis. It goes into that great spreadsheet I was telling you about. Some of our tools, cutters, that we can use, each one of those stay-bolt sleeves represents a point that can leak. And when we reassemble the locomotive, we're going to have it to where we've got this timeline that we're advancing. We don't have time to go back and address dozens and dozens of leaks. So it's got to be right. We'll hydro test the locomotive under warm water pressure and exert 375 psi, and then we move on to the next phase of testing. Well, to get us to that point, we need to make some tooling. It's going to take care of all those rusty sleeves that we saw several slides ago. Plus another tool that's going to rip that weld off, because there's no other practical way to remove all the thousands of welded stay-bolt caps. The big boy particularly has mostly welded caps on it. So this tool right here is going to get a real workout. And that actually is rotating. You can see we're holding it with an overhead crane, and 2 people are running that. You know, this is not for the faint of heart. This is 1940s. Today we would probably do it an entirely different way. Probably wouldn't even weld the thing on there if they knew this is how you had to take it off. But we made that cutter based on a 1920s patent that we researched off the internet. Another shot of the many, many caps going back together. That's our new machinist, Garland Baker, and he's been with us over a year now, but at that time he was maybe a little over a month. And you know somebody's going to work out good when they can do the same job day in and day out, day in and day out. He was up on that man lift, every one of those caps. Never complained once. And here's some more stay bolts. These happen to be out of the 3985. That one is, the head was machined off and we couldn't find that hole that we were looking for.
Yeah.
So we were just trying to do some investigative work when we were making and sourcing our stay bolts. We wanted to kind of determine what kind of metallurgy it was, what had been used previously, and how we wanted to manufacture them going forward. And I put that slide in there again, I don't know why. And here's one of our manufactured components that has a serial number that ties it to its material test report. So in the future, when we do that work on the locomotive, or 10, 20, 30 years from now, somebody gets in there, they know that that is a certified component and that they don't have to remove it or have to deal with it unless it's defective. Another close-up of that telltale hole. That gives you an indication when the bolt is broken. As those stay bolts are under load through the heat, the expansion and contraction, and just the life cycle of a steam locomotive, the proper way to run a steam locomotive and to manage it is to keep your temperature, your pressure, as even as possible. Well, how do you do that when you're running a train? Well, you do it through just the technical skill of being able to manage that aspect of the locomotive. If the pressure varies a lot, that represents additional expansion and contraction, which over time is going to make these parts break and wear out. It's going to accelerate that wear. So what we do, what they're doing right now is they steam the locomotive up. We bring that pressure up nice and gradual, and we let that heat equalize. And once we get that pressure up there, it's there all day. It varies at maximum 10 psi. As we're running down the track, if it drops 5 psi, I'm looking at Ted. Any more than that, and he knows I'm looking at him. But it's just part, all joking aside, it's part of the proper operation of a steam locomotive. So as that bolt is subject to the bending forces of all that tremendous expansion and contraction in that firebox and combustion chamber, over time it can fail. If it goes through a circumstance where that pressure drops rapidly, or you steam the locomotive up rapidly, and you continue to do that over time, you're going to break stay bolts. And as that crack propagates down into that hole, steam will blow out to where we can visually see it when we make our inspections multiple times a day. And that's the purpose of that telltale hole. And there's another one with the absence of the telltale. Well, here's the turret valve on the very top, or excuse me, the boiler check. That's where all the water goes back into the locomotive. As we're going down the track, we're evaporating that water, we're producing power, we're moving the train. And we've got to have a means of putting that water back in. Well, this check valve, of course, very important. As that water is delivered into the boiler, it passes through a check, which is holding the pressure of the boiler inside. The pressure of the feed water device overcomes that and pushes its way past that check valve, and the check valve closes again. It also has a means to shut it off, these threaded portions right there. If that check were to fail, we would lose all of the pressure. And it could be catastrophic in some ways. It could go back through the water pump, go back through the injector, and then here we are out in the middle of nowhere with 800 people on the train and all the water is blowing out of the locomotive and no way to shut it off. Very important device. We rebuilt that 100%. New studs. That's where it goes down into the boiler. We made a fixture to machine that shiny ring you see, and each one of those studs is brand new. And the rivets you see on the outside are what's known as a reinforcing plate. So it's got a very large plate on the inside, one on the outside that actually sandwich that penetration point through the boiler. Very rugged machine, which is why we care for it the way we do. It's approaching 75 years old. A lot of the parts that we were taking off, little by little, piece by piece, we had them on various pallets in the shop and in another storage area. And as we progressed through it, we would just go through each one of those pallets and start rebuilding everything, including the air brakes. So we chipped all the layers of paint off and just progressively went through each component. You can see a lot of rust in there. The older air brake systems were designed to thrive and live many years on a steam locomotive. The newer air brake systems do not tolerate the degree of oil that our locomotive air compressors put out. So if we were to convert this locomotive to the new style of air brake, we could do it, but we'd have that concern. So we like to use the original. It keeps the locomotive original, but it also allows for better functionality when we go to operate these big passenger trains, because we're pulling it with a steam locomotive. So it's only fitting that we have the steam locomotive air brake system pulling that train. It is fully compatible. We went through each one of those pieces, and our locomotive fireman, Ted, was involved in that process. Does two things. He's a very meticulous craftsman, but it also gives him the really advanced knowledge that he'll need to be a locomotive engineer. That's what it looked like as we pulled it apart and put it all back together again. They've got some brand new gaskets from the air brake manufacturer. It was fun working with them. They helped us make some new gaskets. They hadn't heard anybody call for that type of gasket in years. And that's a piston on the inside. It's a really complex system, how it works. It's very similar to the system that we currently have. It just does things in a different way. The modern locomotives use a computerized system. It's got a different systems of valves and pressure switches and various things. Air brake parts going together. It's the before and an after. And it just takes a lot of time. You know, one person doing one aspect of the rebuild. And there it is, all ready to go, ready to get reassembled back in the locomotive. It gives you a really good sense of accomplishment and knowing the thoroughness of how everything was cared for and reassembled when we operate down the track. That's a gasket out of one of the, what's known as a vent valve that actually allows the train to go into emergency. So that's an important gasket. And that's an air filter, likely from a long time ago. And we took that filter component out. You know, we can get a modern version of that. We could get in our parts what we call e-procurement, and we could obtain a modern air filter for that locomotive. Well, we're making this locomotive, we're restoring it. It doesn't take that much time to just restore what we have. And we couldn't find an air filter element, so we got on the internet, and for those race car aficionados, you know what a K&N filter is. Some more air brake components that we rebuilt. You'll be able to see that as you walk up and walk around the locomotive. The fireman's side is facing where you'll be walking, and you'll be able to look right up there and see that. That's what we call our coded cab signal safety control system, and that allows the locomotive to be compatible with the main corridor from Omaha to Ogden. They have a safety control system. It's an electronic system that will stop a train in the event the engineer doesn't respond to the air brake or the signal indication. A close-up of the workmanship. Now we're going to be inside the boiler. Once we get everything reassembled, we have to go through a series of tests. And when we subject the locomotive to pressure beyond the allowable working pressure, we have to do an internal inspection. Make sure nothing broke loose. Make sure we haven't had any failure of any kind or nothing that we need to address. Back here, this is the Firebox, and each one of those is known as a radial staple. All those welds and all those bolts we were talking about. And these are the tubes and flues that we put in. We put the tubes and flues in a matter of days. In the true spirit of the Union Pacific and our crew, we had one little thing after another that was kind of creeping up on us. And we just address it with the same spirit that we've addressed all the complications. And we just, we deal with it. Now here's that refractory. I took this picture not long after I vacuumed, and the little swirly marks is the vacuum as I was vacuuming out the soot. And that black hole in the center is where the burner is, and that's where the fuel is atomized, and it burns in a very large flame heading back toward where we sit in the cab, and it curls up, and that intense heat of that fire radiates and transmits through all those metal surfaces that you see. And then it moves through the tubes and the flues. If you were to look in the firebox, if we had a fire in it, you could look up and see all those tubes and flues. This was not long after we installed them. And again, you know, this work was progressing very rapidly. Now we've advanced beyond the testing and the evaluation phase, and now we're putting the locomotive together. Every day there was progress. If you came in and a week later you saw it, you wouldn't recognize the locomotive. We had to put the number 4 driver back in, and then put all the connecting rods and put everything back on the locomotive, getting it ready to go. putting the cab back together, all the piping, everything that goes back together. Very meticulous, painstaking work. Some of it has to go on before others. It just has to go on in a sequence. Now, once we've completed the hydrostatic test, we're going to steam test the locomotive. We've passed that test. Now we actually are going to steam it up. Well, to steam it up, we need to have the cab, and we need to have all the control apparatus so we can control the fire, control the blower. Well, in order to get that on, we have to get all these other subsystems on too. So it's critical that we not have any problems, because all those systems are going to have to come right back off again if we have an issue. So that's why it's so careful that the quality control is always absolute. There's the air brakes going back in, speedometer, and what we call our MU controller. This allows us to couple to a modern diesel locomotive and control it. So you can control the steam locomotive and the diesel all from the engineer's seat. It's a very versatile device. It's not to say that you can't coordinate on the radio to tell somebody what to do back there, but it's far more easy, makes for just a nice, smooth, seamless operation when you're controlling that diesel. We rebuilt this. This is actually a brand new unit that our electrician made in-house. Now we got to paint the locomotive and continue to put together all the various parts of it. Lots of long days up there, many weekends. That's a picture I took as I'm standing looking down into the boiler, making one of the final inspections before we put the dome cover on and we seal the pressure vessel up and start filling it with warm water. And then, of course, painting. Very versatile team of professionals. There's nothing that they can't do. Going through some operational tests on our new controller box. Got a speedometer there right next to it. A modern speedometer integrated into a steam locomotive. And we pushed the locomotive out a little bit. We light a fire in it. We allowed, we talk about things a lot, how we want to do things, and I've become a person, I like a lot of ceremonies, or, just these really critical milestones. So we designated Jimmy Thompson to be the first one to blow the whistle. And he and Garland Baker, our newest two members of the team, they lit the flare, it's like a highway flare, and threw it in the firebox to light the first fire. And we all gathered in the cab, we said some words, and it's a very huge milestone. And for months we talked about that point and where we're going to be and what it's going to take to get us there and why we have to take so long and be so meticulous about things. So to have that opportunity and everybody present when it happens, I mean, it's hard not to be emotional. But it is. It's emotional. Oh, great picture here. Side rods on the locomotive, coat of paint on it. We're getting the brakes together. To take a driver out, we got to take a lot of things apart on the inside. So it's just a lot of reassembly. 2 months ago, this didn't look anything like it. And there's Jimmy Thompson. We're making a last-minute device in the cab. And that's how it looks when you'll see it here in just a short while. This is we actually made that back in 2011. I took over as manager in 2010, and we began to kind of look at the locomotive, and there was a lot of stuff we had to do to keep running it. We were going to run the 3985 for a while. We were going to do some work on the 844, and we discovered some pretty significant problems with the Challenger. Well, now we've got to focus our efforts on that 844, so that we shifted our focus, and so we made that piece fit in the floor, and we took that out and we actually fit it here. It actually comes out and allows us access to the air brake components down underneath the floor. So as we put all this together, we're thinking about how we can make it so it's going to be easier for us. We got to get to some of these parts down there routinely to inspect them and repair them, and sure enough, you're traveling down the road at 60 miles an hour and you got a little part that's malfunctioning. Well, the staff was involved in every aspect of this. So there's no part of that locomotive that's foreign to anyone. There's a problem, they have a very good idea where it is. And we have a tremendous library of technical information. I'll go through and I'll print out all these old files that I have. And I'll walk them through and I'll make a copy for every member of the staff. Here's your copy of how to rebuild the air pump. Here's your copy of how the throttle works. Here's your air brake book. You know, so everybody has that technical knowledge and continues to build on it. And it's a crew of people that is really, they're really passionate, as you'll see. You know, they're over there right now, I guarantee you they're cleaning it. They're wiping down the rods. A couple of them are in the cab, wiping the floor, cleaning things. Once all the important work is done. So that comes from the pride of having your hands on the project from start to finish. So it's a pleasure to work with them, and it's such a pleasure to be able to operate a steam locomotive, 2016, on a modern railroad. So it's something that we're very proud of. We're proud to represent the Union Pacific, and we could not do it without their support. So when you see UP people, they're behind us, and they've made this happen. Without them, we'd be nowhere. So real quick, I think that's about it. I think that's a record presentation. Usually I use like 2 hours. But please bear with the technical stuff, and I appreciate it very much. And does anybody have any questions before we go over?
Did you say you throw a highway flare in to start this?
Yeah. Yeah, that's, well, we could use, yeah, it's called a fusee. We could light a match and put some diesel fuel on some rags, and sometimes you do that. But the highway flare is easy. You pour it in there and off she goes.
So the 4014 was built by the same company, too much earlier. So I assume there's a lot of commonality, so that when you presumably you already have started on it, you've got a big head start from this project. Is that true?
Yeah, his question was the big boy was built by the same company, American Locomotive Company, and the commonality of parts, and that's correct. We've started on the big boy, but this project was our priority, the 844. We're starting on Monday. You know, I jokingly told our boss, Harvey, I said, he said, why don't you take some time off? And, but we're excited about it. Yeah, all the tooling, we already have many things that we've already bought. You know, when we're buying staples for the 844, we buy enough for our other projects. Staples, staple material, cast tooling, I mean, everything that we have, everything that we need, it all translates into additional work and further work on the 4014.
Where was all this work done and how many people were involved?
Our question was, where was the work done and how many people? Done in Cheyenne, Wyoming, by our staff that you'll meet here in just a few minutes. We have a staff of 14. And you consider the amount of work that's done. There's some areas that you can only get a couple people in the Firebox. But everybody just working tirelessly, working together in one capacity or another, whether it's helping with some of the IT issues we have, because you identify people's strengths and their talents and the things that they like to do. And our conductor, for example, is probably one of the most efficient procurement specialists on our railroad. And he knows and has developed a network of contacts that can make us or allow us to get things the right way. Because you can imagine a big corporation, a big railroad, you've got a process in place for so many things. You just don't go out and buy whatever you want. So it's fabulous.
To put on that though, good for Ed. He's definitely sharing some of the credit, but to answer your question more specifically, there's a core group within that 14. There's just about 8 guys that spent nearly the last year.
7 days a week.
7 days a week. Some of us, like myself, do some periphery things, but that core team of 8 really deserve the credit. They put their heart and soul into it for sure.
Well, thank you. That's without people pulling in the same direction. You know, there's people that I've worked on a lot of steam locomotives. My foreman, who you'll meet, And he's quite young, and there's a lot of youth on our team. And there's several who's been around a while too. But we're developing that team of individuals that is going to care for this locomotive. Because when you look around, when you're out there, when there's problems, there's not a truck pulling up with a bunch of people coming out of that truck helping you with your steam locomotive. You're it. And so they have to have the technical expertise to get it done. And that comes from passion. You know, this is a job that you gotta want to do. A lot of people on the outside looking in, oh, that's great, I can't believe you guys get to do that. Believe me, it's very difficult, it's arduous, it's one of the most demanding jobs because of the pressure of what we have to do, and it's a big machine. It's hot. A lot of people can't even endure the heat. So, yes, sir.
Given the size of the boiler on a 4014, would you have to outsize or outsource that job of replacing the flues?
The question was, given the size of the boiler, it's actually not that much bigger. Yeah, the flues are only 2 feet longer, and the 844 has 58 superheater units. The big boy is 73. It's got 198 tubes or flues, and the big boy's got 212. It's really not that much bigger. Firebox is bigger, and it's quite a power plant. As you'll see if you go out here and look at the 4005. But it develops its power the same way the 844 does. We'll be able to do everything, a lot of things in-house. And that's our philosophy. When you outsource things, people either come in with a workforce with skills and expertise and tooling, and they perform the work for you. And hopefully that work is of high quality. And when they go away, that expertise, the tooling, and those people go away. And we're left with a completed project, but where do we go from here? So when we have staff that is passionate and they really want to learn, and we're committed to giving them the skills, the training, whatever they need to develop that, so they can do the work. So going forward, we now do that work scope. And who better to do it than us? As a matter of fact, is our saying, if not us, then who? So, yes, sir.
And do you have any plans for the other FDF3 that you have in the roundhouse?
That's our parts source, and it has been, and it's been serving in that role. We're going to use the major parts of it still today. We're looking at the tender tank. The water space on all our tenders is very deteriorated, so that's a good candidate for us. We've got a spare set of drivers that we'll rebuild for the 844. You're looking at a machine that's been in continuous service since 1960. Imagine the millions of miles. When you're looking at the wheels over there, we've replaced the consumable parts of it, but the core bearings and the axle is original. How many millions of miles are on that equipment? Eventually, it's got to be addressed. So to do that, we'll take the drivers off the 838, rebuild them, get them exactly the way we need them, which is no small task. And then we'll swap them out with those on the 844. The side rods too. Piston rods, all that machinery that you see moving down the track is wearing metal against metal, and it doesn't last forever. The piston rods are small. They're getting worn out. We gotta make the piston rods. Well, when you do the big boy, we're gonna do the 844 too. So not only have we built up everything that we need for the big boy when we're doing the 844, but as we do the big boy, we're gonna step back and we're gonna make some parts for the 844 as well. Because sourcing those big forgings and sourcing that metallurgy is something that takes a little bit of time, a lot of lead time involved with that. And we just don't have the time sometimes to address those issues, especially when we're doing this kind of work. The question was, can we design an oil burner for the big boy? Well, we have the drawings for what they did to this locomotive. The 4005 was the one that converted. And unfortunately, all of those records and everything were destroyed. I've heard a couple different stories on how they were destroyed, so they don't exist. I've read things, a lot of people have read whatever's available. We have no doubt that what we'll do to convert it to an oil burner will work. When you look at other locomotives that were oil burners, several of them had a firebox grade area bigger yet than the big boy. So it's just a function of having that correct design. And the Union Pacific design that we'll use is not far off of what they developed when they converted that class of engines. And they did it as a temporary measure. If the coal strike were to continue and other economic factors, they may have converted the others. But had they needed to make that big boy work as an oil burner, you know they would have. So that's where we find ourselves. And I have no doubt what we'll do will work. Yes, ma'am?
What does it cost you to refurbish one of these things?
The question was, what does it cost? And I get that a lot. And it's a significant sum of money, but it's not as much as you'd expect because we're very resourceful. We're accountable like all the other departments on the railroad. But we allocate, we use the resources that they give us very, very wisely. And you know, we're very fortunate that they fund this entire concept of the Heritage Program. Not only our end of it, the steam shop, but there's an entire other arm of our department back in Council Bluffs that maintain those beautiful cars that you're going to ride in tomorrow. So this represents a commitment to preserving the heritage of the railroad. Sometimes when people are asking me that question, I tell them about $1,000. and it gets the same response. But you know, this, imagine having the opportunity. We have a well-equipped shop, and we are all working together, utilizing all of our tools and all of our time as wisely as we can to make this work.
So, if 844 is good, and it's going to be used tomorrow, obviously, what else is it going to be used for? Is it always going to be used to pull this train for other special events? Is it?
The question was, what is 844 used for? Is that decor? It's a absolute, the best public relations ambassador a railroad could have. It's just a fabulous machine. Community outreach, employee outreach, that's its role. And we haven't announced the trips that we'll make later on in the season. They're still evaluating those. But we go where they tell us. And it's a fabulous public relations tool for the railroad. It is in this exclusive service. It's assigned to the executive department. So it's used to travel, and it's a great outreach tool. Pulling freight trains and things like that, it's great for, we would like to do it, rail fans would like to see it, and maybe someday, if that meets the public relations or the corporate objective, we'll do something like that. But for now, she'll be pulling the Frontier Days train tomorrow.
Would it ever go like, do they go to the Super Bowl every year on the train, or was that just one time last year?
Could it go to the Super Bowl? Sure. There again, if that's where they want us to go, it'd probably be a real detraction from the Super Bowl. You know, depending on what team you'd be cheering for. People be down there looking at that neat Union Pacific steam locomotive. I'm biased, of course. Okay, everybody. Well, the guys are going to be over there, and they love to answer questions too. And they're very humble, but they are the ones that have done the work. So I'm excited to have you meet them. Thank
Hey, Ed,
you.
you want to mention, folks, if you're driving over, I think some or most are walking, but if you're driving, look for the white UP vehicle. We're going to pilot the parade of vehicles, so please don't head out on your own. We want everybody to assemble. So if you are driving, you just follow behind the UP vehicle in line, please.
As we park over there, parking may be limited, so what we'll do when we get over there, we'll kind of play it by ear a little bit, but I might be your traffic cop, and we'll try to in as best as we can, organize parking such that we can all walk over and enjoy the locomotive. And just one other thing, it is a dirt parking lot, so please be mindful of the walking conditions and, you know, potholes and things like that. So everybody just take your time walking over there. Thank you.
Thank you very much.
What's our time frame? What room heads back to get cleaned up and that sort of thing?